The periodic table. If you look at the elements on the periodic table, they all have a top number, which is the mass number, and a bottom number, which is the atomic number. If you start at hydrogen, work your way across to helium, come back down to the next row and work your way across, and the next row and work your way across, both the atomic mass and the atomic number increase. Because the atomic number and the atomic mass both increase up to argon in the periodic table, it would be easy to think that the atoms on the periodic table are arranged in both atomic number and mass number order. However, once you get to argon, you will see that there is a slight change. The symbol for argon on the periodic table has a mass number of 40, an atomic number of 18, whilst potassium, the next element along, has a mass number of 39 and an atomic number of 19. This makes it quite clear to us that the periodic table must be arranged in order of atomic number, because that is the only one of the two numbers that consistently increases. Argon and potassium aren't the only pair on the periodic table that do this, so you need to make sure that you can spot them if necessary, because you can use them to explain to the examiners that the periodic table must be arranged in atomic number order. As well as being arranged in the order of atomic number, the elements with similar properties are in columns which are known as groups. So, for example, boron and aluminium are in group 3. Carbon and silicon are in group 4. The rows on the periodic table are called periods. The row which has hydrogen and helium in is the first period. The row which runs from lithium to neon is the second period, and so on. If you're trying to work out what period an element is in, it's always wise to count your periods using the right-hand side, because if you look at the left-hand side, there isn't an element on the hydrogen-helium row, so you'll end up with a period number that is one less than it should be. The reason the table is called the periodic table is because elements with similar properties occur at regular intervals, and we can use this to predict the probable reactivity of elements. So, for example, we know that sodium reacts violently with water, therefore we will be able to predict that all of the elements in group 1 will react violently with water. The periodic table and the position of the elements in it is directly linked to the electron structure. For example, sodium has an electron structure of 2, 8, 1. If you look at the final number of the electron structure, you can see it is 1. This corresponds with the group that sodium is in. So, we can always use the final number of the electron structure to tell us the group that the element is in. Sodium has 3 shells being used, and not coincidentally, if we count down, sodium is in the 3rd period. So the number of digits in the electron structure, or the number of shells if we do the drawing version, will tell us what period the element is on the periodic table. Another example. Calcium has the electron structure 2, 8, 8, 2. If we find calcium on our periodic table, you can see that it is in group 2. If we go across, it would be in period 4. This ties in with what we can see from the electron structure we've written. The final number is a 2, so it's in group 2. There are 4 digits showing that there are 4 shells, and therefore calcium is in the 4th period. The only time we come across anything strange is when we look at anything in group 0, because we never actually write an electron structure with a 0 in it. The easiest way to think about this is to consider what actually happens to an element when we get to the far side of the periodic table. So for example, neon has an electron structure of 2,8. The final shell on neon is full, and that effectively is what group 0 means. We can't call it group 8 because helium has a full outer shell, but it only has 2 in. So scientists use group 0 because we imagine that the next shell is ready and waiting with 0 electrons in. Neon, as we can see here, is in period 2, which corresponds with the fact that it's got 2 digits, and therefore it's got 2 shells.